So in this video, we're going to discuss the basics of the derivative for a given hyperbolic trigonometric function. So ito, this is another type of trigonometric function na dapat natin alamin. So commonly, we have sin x, right? Wait lang. Sin x, cosine x, tangent x, and other three more trigonometric function. So there is a version of it na hyperbolic siya, which is basically ganito siya. Sine h of x, cosine h of x, or hx na lang, then tangent hx. How do you literally describe this function? Basically, this is hyperbolic sine x. Ito naman, hyperbolic cosine x. At ito naman, hyperbolic tangent x. Alright? Pero yun nga, it's so long to just simply name these so-called hyperbolic trigonometric functions. You can just, literally pronounce their function na lang. Like, instead of hyperbolic sine x, why not just say sine hx? Yun na lang. For simplicity lang naman to eh. Okay? So, dito pala, they have their own also, what do you call this one? They have their own identities as well. Alright? So, kunwari, itong si sine hx. This one actually is just the same as e raised to x minus e raised to negative x all over 2. Tapos si cosine hx is basically e raised to x plus e raised to negative x. Okay? All over 2. Alright? So, paano naman kaya kapag tangent hx siya? Okay? So, alam niyo yung reciprocal identity? Yung kumbaga, sine x is just the same as 1 all over cosecant x. Cosine x is just the same as 1 all over secant x. Yung mga ganun. The same din sa hyperbolic trigonometric function. So, kung dito, if we have tangent x as sine x all over cosine x, then we have tangent hx as sine hx all over cosine hx. And we all know that, sorry. Kala mo naman alam na agad eh. And since sine hx is just the same as e raised to x minus e raised to negative x all over 2, and cosine hx is e raised to x plus e raised to negative x all over 2, so this would be e raised to x minus e raised to negative x all over 2 all over e raised to x plus e raised to negative x all over 2. Okay? So in here, pwede ko itong i-simplify. Okay? Since on the numerator, meron tayong all over 2, di ba? Which is just the same as 1/2 of e raised to x minus e raised to negative x all over 1/2 of e raised to x plus e raised to negative x. We can cancel 1/2 on both sides. Magiging 1 na lang to. So hence, tangent hx is just the same as e raised to x minus e raised to negative x all over e raised to x plus e raised to negative x. So that is tangent hx siya. So yeah, ganun lang naman siya. Alright? So yeah, these are the basic identities para sa hyperbolic trigonometric functions. And there are actually, let's just say, marami pa na dapat yung alamin. But we will get onto that like soon. Or better yet, i-research nyo na agad sa YouTube or sa Google. Because dito, maybe we're going to apply it dito directly. Alright? So now, let's proceed to differentiation. Okay? So, let's start first with this one. the derivative of sine hx. So this one, the same lang sila ng format sa pagkuha ng derivative ng sine x. Remember that the derivative of sine x is cosine x. So this one is just the same as it is. So ang derivative ng sine hx is cosine hx. So let me give you some examples. So let's just say meron tayong derivative of 3 times sine hx. So what would be your answer? So ito, okay, we will have 3 times the derivative of cosine hx. So in here, 3 times, ay, bakit cosine hx? Sine hx to dapat eh. Forgive me. Yeah, sine hx. Okay, so derivative ng sine hx, so this is cosine hx. So combined together, yan na yung sagot mo. 3 times cosine hx. So that is your answer. Or pwede namang siyang maging 3 all over secant hx. Remember, yung sinasabi kong reciprocal identity or yung quotient identity nila, if I'm correct, yung kumbaga parang yung sine x is the same as 1 all over cosecant x. Cosine x is the same as 1 all over secant x. Diba? Yung reciprocal identities ng trigonometry is just the same as sa hyperbolic trigonometric function. Hence, kung alam natin na si cosine x is the same as 1 all over secant x, then we can rewrite as cosine hx as 1 all over secant hx. Okay? So let's have one last example. So let's just say meron tayong negative 3 halves of sine hx. So in here, ganun din, we will have negative 3 halves times the derivative of sine hx. So in here, we will have negative 3 halves times derivative ng sine hx cosine hx. So ipag-combine mo lang sila, we will have negative 3 halves of cosine hx. Or pwede mo namang siyang ipagsama si cosine hx kay 3. There's no problem. Okay? Or you can just have negative 3 all over 2 times secant hx. So, pwede rin ito. Okay? So yeah, that's it. To sum it up, the derivative of sine hx is cosine hx. So next is the derivative of cosine hx. So the same din na format sa pagkuha ng derivative ng cosine x. Remember, hindi, actually, no, not the same, but similar. Okay, similar sila, not the same. Remember, di ba, ang derivative ng cosine x ay negative sine x. Dito naman, on the other hand, it's positive sine hx. So yeah, similar, sine pa rin, pero negative, positive nga lang siya. So therefore, the derivative of cosine hx is sine hx. No changes. So let's have some examples. So let's just say meron tayong derivative of pi times cosine hx. So in here, magiging ganito na siya, pi times the derivative of cosine hx. So remember, derivative ng cosine hx is sine hx. So we will have pi times sine hx. So pwede na to, or we can have pi all over cosecant of hx. Cosecant hx. Okay? So both of them are correct. No changes at all. Parehas naman siyang tama. So how about another one? Let's just say we are asked to get the derivative of pi all over 3 times cosine hx. So, this one, meron tayong pi all over 3 times derivative ng cosine hx. So, in here, derivative ng cosine hx is sine hx. So, therefore, ang sagot natin dito is pi all over 3 times sine hx. Or, we can just have, we can just have pi all over 3 times cosecant hx. Diba? It's easy. So yeah, bottom line, the derivative of cosine hx is sine hx. Next is derivative ng tangent hx. So ito naman, ang format naman nito is just the same as format ng derivative ng tangent x. Remember that ang derivative ng tangent x is secant squared x, diba? So the same thing here. Okay, ang derivative ng tangent hx is secant h squared of x. So the same lang sila ng format. So let's have some examples. So let's just say we have the derivative of 4 times tangent hx. So dito, you will have 4 times the derivative of tangent hx. So the derivative of tangent hx is secant h squared x. So therefore, meron tayong 4 secant h squared x. Yan. Or, pwede namang gawin natin siyang 4 all over cosine h squared x. Alright, that's it. Okay, you can simplify this one further kasi meron tong Pythagorean identities ng hyperbolic trigonometric function, which is meron lang silang slight difference lang compared dun sa Pythagorean identities ng common trigonometric function. Okay? So next example natin, let's just say meron tayong derivative of 44 times tangent hx. Okay, so this one, we will have 44 times the derivative of tangent hx. Okay, so remember, derivative of tangent hx is secant h squared x. So, okay na to. Or you can have 44 all over cosine h squared x. So bottom line, derivative ng tangent x is secant h squared x. Now let's talk about yung derivative ng secant hx. So dito naman, meron siyang slight difference dun sa derivative ng secant x. Recall, di ba, ang derivative ng secant x ay secant x times tangent x. Dito naman, ganun din ng format pero negative siya instead. So we will have negative secant hx times tangent h of x or hx na lang. Ayan. So meron siyang negative na lang siya. So let's have some example. Okay, some examples. Yun, there we go. So let's just say meron tayong derivative of e times secant hx. Is e a constant? The answer is oo. Constant pa rin si e. Kasi si e is Euler's number yun eh. Euler's or Euler's, ano bang pagka-pronounce niya? E is an irrational number. Unless meron siyang x dito, iba na yun ha. That's already a different scenario kasi exponential function na yan. However, kapag e raised to 1 or e raised to negative 1 or e squared or whatsoever, constant pa rin siya. It's still a constant. So, that means we will have e times the derivative of second hx. Ganyan yung maging resulta. So, derivative ng second hx, we will have negative second hx times tangent, bakit may ta? Sorry, tangent hx. Alright? So we will have negative e times second hx times tangent hx. So pwede na to, or you can still simplify this one. Remember na si second hx is just the same as cosine of hx, and tangent hx is just the same as sine h of x all over cosine h of x. So multiply them together, we will have negative e times sine hx all over cosine h squared of x. So, pwede na rin to. Alright? Now, let's have another example. Let's just say meron tayong negative 9 times second hx. Okay? So, we have a constant negative 9. So, we will get the derivative yung katabi niya, which is the second hx. So, once again, anong derivative ni second hx? So, this would be negative second hx times tangent hx. So, kunin natin yung answer nito, you will have positive second hx times tangent hx. Or, you can just simply have 9 times 1 all over cosine hx times sine hx all over cosine hx. So if we're going to multiply them together, I think nabulol ako nun. So if we're going to multiply them together, ganito yung magiging resulta niya. 9 times sine hx all over cosine h squared of x. So, parehas naman silang tama. So yeah, overall, ang derivative ng second hx is second hx times tangent hx. So next is cosecant hx. So ito, si cosecant hx naman, ano siya, the same lang format ng pagkuha ng derivative ng cosecant hx. Okay, parehas lang naman sila. So remember na yung derivative ng cosecant x is negative cosecant x times cotangent x, di ba? So the same thing here, same format, meron din siyang negative. Ano nga lang siya, meron siyang h kasi hyperbolic. So magiging negative cosecant h times cotangent h of x. Yan yung, wait lang, ayusin ko to. Yan yung derivative ng cosecant hx. That's it. Now, what we're going to do is we will now, have some examples. So, kunin natin yung derivative nito. Let's just say negative 3.14 times cosecant hx. Itong si negative 3.14, considered pa rin siya as a constant kasi number pa rin siya. So, mangyari yan, we will have negative 3.14 times the derivative of cosecant hx. So, in here, magiging negative 3.14 times derivative ng cosecant hx, we will have negative cosecant hx times cotangent hx. Ayan na. So, multiply together, we will have negative 3 tuloy. Positive na to. So, we will have positive 3.14 times cosecant hx times cotangent hx. Hx pala to guys, sorry. Hx. Ayan. So, pwede to, or you can still simplify this one. So 3.14 times 1 all over sine hx times cosine hx all over sine hx. So yun, combine them together, we will have 3.14 times sine tuloy, cosine pala to, cosine hx all over sine h squared x. O, diba? Pwede lang yan. Now, one more example. Let's just say you're asked to get the derivative of, sabihin nating 3/4 of cosecant hx. Alright? 3/4 of cosecant hx. So this one, we will have 3/4 times the derivative of cosecant hx. Alright? So this would be 3/4 times negative cosecant hx times cotangent hx. So combine them together, magiging negative 3/4 times cosecant hx times cotangent hx. Alright? Or, pwede ito maging 3/4 times 1 all over sine hx times, cosine hx all over sine hx. So yun, ipag-combine mo lang sila, you will have negative 3 times cosine hx all over 4 times sine h squared of x. So yun. Ang bilis ko magsalita, no? Pero basically, yeah, derivative ng cosecant hx is negative cosecant hx times cotangent hx. Then combine them together, ito na maging sagot mo. Alright? Ito pala, ba't ko to chinikan? So yeah, yan na yung sagot mo. Or, you can simplify this one into cosine hx and sine hx function. Ganito magiging sagot niya. Negative. Yan. Yan. So that's it actually. That's it naman. So yeah, overall, derivative ng cosecant hx is negative cosecant hx times cotangent hx. So last na hyperbolic trigonometric function ang didiscuss natin is yung, mali ang pen color ko. This is supposed to be black. So going back, the last derivative rule para sa isang hyperbolic trigonometric function, which is the derivative of tangent hx. So, tangent pala. Bakit tangent? Sorry. Cotangent pala. Cotangent hx. So, ito, yung derivative nito, the same sila ng format ng derivative ng cotangent x. Di ba ang derivative ng cotangent x is basically negative cosecant squared x. So, the same format lang sila dito. We will have negative cosecant h squared of x. So, ganun lang siya. So let's have two examples for this one. So let's just say, meron tayong derivative ng, let's just say 51. 51 times cotangent hx. Okay? Yan. So this one, I can simply rewrite this as 51 times the derivative of cotangent hx. So, ang derivative ng cotangent hx? So, basically, this is negative cosecant squared, cosecant h squared x. So, magiging negative 51 times cosecant h squared x. So, pwede ito final answer. Or, you can just simply raise negative 51 all over sine x. So, pwede na to as your final answer. Okay? Next, let's just say meron tayong ganito. Sabihin natin meron tayong 10.49 times cotangent hx. Okay? So once again, itong si 10.49, kahit naka-decimal, ano pa rin siya? Constant pa rin siya. So this would be 10.49 times the derivative of cotangent hx. Ayan. So in here, derivative ng cotangent hx is negative cosecant h squared x. So therefore, kung multiply mo sila, magiging negative 2.49 cosecant h squared x. Or, you can just simply rewrite this as negative 10.49 all over sine h squared x. O, diba? So yeah, bottom line, this is basically the derivative of cotangent hx, which is negative cosecant h squared x. Ngayon, how about we combine these hyperbolic trigonometric functions sa sum and difference? Kumbaga, they are grouped together and each of these functions are separated by the addition or subtraction operation. So, ibig sabihin pang sum and difference na to. So, ganun din naman actually. Basta simple substitution and simplification, okay na yun. So, we will discuss about that next time. All right? So, yun lang naman guys. So, I hope you have learned something in this video. All right? So, see you soon.